I want you to suppose you have a cat. Well, half a cat. Furthermore, suppose that someone gives you another half a cat. And if we assume that you haven't got two of the same ends, then, well, half a cat plus half a cat should be a whole cat. There's a different way to think about adding my half cats. What I want to do is just add the two 1/2s together to get a whole, and then factor the cats out of the addition. This is just the distribution law in reverse, and it's called factoring a common term. However, I like using the word extraction because I think it's much more descriptive of what we're doing. We are extracting the like term from a sum or a difference. And that's really key here. You should think extraction if you have some repeated symbol across an addition or a subtraction sign. The choice of 1/2 a cat plus 1/2 a cat was arbitrary. I could have chosen A cats and B cats. If I started with A cats and someone gives me B cats, then it makes sense that altogether I have A plus B cats. That's the basic idea behind extraction. Let's look at a few more traditional examples. Suppose I have 3x plus 2x. Well, the x's are common to both 3x and 2x, so they need to be extracted. Here's a little bit more challenging example. xyz plus 2xy. Can you see the cats here? Look closely. Next, let's look at 8x squared minus 30x. 8x squared is 4x times 2x, and minus 30x means minus 15 times 2x. So 2x is the common term. Extract the 2x, and we're left with 4x minus 15, all times 2x. By the way, since multiplication is commutative, you can extract the 2x first and write the 4x minus 15 last. Next, let's look at 27x cubed minus 15x squared. 27x cubed is 3x squared times 9x, and 15x squared is 3x squared times 5. There's a common factor of 3x squared, so we extract it. What's left behind is the 9x minus 5. How about negative 2xy squared minus y? Well, both of the terms have negatives, so we can factor that. And they also have y's, so we'll factor out a negative y from the first term. And in the second term, we can factor a negative y, and we're left with a negative y times 1. So altogether we have negative y times 2xy plus 1. If you're going to make a mistake, it's probably going to be here. You need to remember that when you factor a negative, to change the sign. Let's look at 3 times x plus 4 plus z times x plus 4. Well, this is like our first cat example. X plus 4 is the common term, so we extract it, and we're left with x plus 4 times 3 plus z. Here's a more challenging example. X squared plus 6x plus 2x plus 12. We're going to factor these in pairs of 2. First, look at what x squared and 6x have in common. Well, they have x in common. We'll extract the x, and we're left with an x plus 6. and the second pair, 2x plus 12, well, they both have 2's in common. So we extract the 2, and again we're left with x plus 6. Now don't stop here, because x plus 6 is now common to both of those terms, so we can extract it. And we're left with x plus 2 times x plus 6. I hope that you learned that your math teacher doesn't know how to draw, and a little bit about factoring and extraction. Thanks everybody. I'll see you in class.